Hello everybody, welcome to part 2 of our playlist. So in the first part, we have completed with the first step of machine learning, that is to gather the data on which our machine learning model will be trained. So in this part, let's get started with our second step, which is data pre-processing. So before diving into the code, let us first understand what are the shapes and dimensions of an array. So if you have basic knowledge about any programming language, you must be knowing what are arrays. Let me take one simple array. So let us say that this is an integer array. It has the following three elements, 1, 2, and 3. Now this is the normal array. This array is in fact a one-dimensional array. So why is it one-dimensional? It is because we can represent its elements on a single axis. So we can also visualize this array like this. This is the first compartment, this is the second compartment, and this is the third compartment. So the first element will be stored here, that is 1. The second will be stored here, that is 2, and the third will be stored here, that is 3. Now let us see what are two-dimensional arrays. So two-dimensional, except one-dimensional arrays, all of the other dimensional arrays are nested arrays. So this is our main array, and now there will be two arrays nested in this array. So this is the first array, this is the second array. So this or these two arrays will now have the elements. Let's say those are 1 and 2. Similarly here 1 and 2. So this is what is known as two-dimensional array. So let us again visualize this array. So let's say our new array has two compartments. The first compartment will have another array and the second compartment will have yet another array. And these arrays will finally store the elements. So here is our first array. This has 1 and this has 2, and here is our second array. This has again 1 and this has again 2. So as you can see here, the size of these arrays which are inside our main array is the same. So like this array has two elements, also this array has two elements. This is very important in Python. You can't have arrays in which the inner arrays have different sizes. So this is two-dimensional array. Now why this is a two-dimensional array? It is because we have to represent it along two axes. We cannot represent it along one axis. So let's say x and y, we can represent it along x and y. Now this is what is known as two-dimensional array. Okay, so now let's see what are three-dimensional arrays. So first we will have our main array. Then at the first position of our main array, we will have another array. And now this array will have another array. So this is our first array and this is the second array. And these two arrays will have our elements. So 1, 2, 1, 2. Now let's close this array. Again, at the second position of the main array, we will have another array. Again, this will have another array. So 1, 2, and on the second position, yet another array, 1, 2. Let's close this array and then let's close the main array. So this is what is known as three-dimensional arrays. So speaking geometrically, we need three axes to represent the three-dimensional array. So like the x-axis, y-axis, and the z-axis. So now, as you can see again, the sizes of the elements inside the array are same. So like here, 1, 2 elements are present. So here also two elements, here also two elements, and here also two elements. So now let's try to visualize this three-dimensional array. So let us suppose this is our main array. We have again two compartments. The first compartment, as you can see here, this is the first array. So the first compartment will have another array. Now again inside this, as you can see, there are two arrays. So let us make again two compartments, and this compartment will finally store the array which has the elements in it. So 1 and 2. Again this compartment will store the another array which has the elements in it, which are those are 1 and 2. Similarly, this compartment will have another array, and again this will have two compartments, and this will have another array, 1, 2, and this will have another array 1 comma 2. So to understand it more clearly, this compartment belongs to this array, and this compartment belongs to this array. Um, my bad. This compartment belongs to this array, and this main array is what is represented by these brackets. Again, as you can see, this is the first position and this is the second position. So let us see again hierarchically. This is the first array, this is the main array, which we have represented it by this box. Again, this has two compartments. So first position, second position. In the array, it is programmatically it is indexed as 0 and 1. So zeroth position and the first positions. So let me erase this. So this is the zeroth position of the main array. This is the first position of the main array. So inside this we have another array. We have represented it by these brackets. So again, this will have again the zeroth position and the first position. At the zeroth position, this array stores another array, and finally inside this array we have the elements. Similarly, this is another array which is stored at the first position of the main array, and inside this there will be two arrays again at the zeroth position and the first position, and again inside that we have, and finally inside that we have the elements. So this is what is known as three-dimensional array. I know that it is slightly complex to understand as compared to first one-dimensional and the second dimensional. So to understand this more concept more clearly, let us go back to the one-dimensional array. So as I told you before, this is our one-dimensional array. Let us again try to visualize it. So let us assume that this is our array. It has three compartments. One, this is the first compartment. Then this is the second compartment, and this is the third compartment. Here we have our first element stored, that is 1. Here we have the second element stored, that is 2, and here we have the third element stored, that is 3. So this is a very common array, and this is what is known as one-dimensional array. Now let's make this 1D array more complex. So let's move forward to 2D array. So in this array what we have is, let us again try to visualize. This is our main array. So according to this example, it has two elements. So we need to make two compartments in this. So this is the first compartment and this is the second compartment. So at the first position and at the second position we have two arrays. So while representing it programmatically, it is indexed from 0. So this is 0th position and this is the first position. So at the 0th position, we will have yet another array. So let us represent it by another compartment or another box. And the first position, we will have yet another array. And finally, this array has again two compartments. So this is the first compartment, and this is the this is the first compartment, this is the second compartment, and again this array will have two compartments. This is the first compartment and this is the second compartment. And finally, this array will store its elements. So 1, 2, and again 1, 2. So this outer box is our main array represented by these brackets. So total we have two arrays. The first array is placed at the 0th position and the second array is placed at the first position. So this box is represented by these brackets and this box is represented by these brackets. So inside this we have two elements 1, 2, 1, 2. So this is what is known as two-dimensional array. Now let us make it more complex. We'll move to three-dimensional array. So again, let us try to visualize it. Let's say this is our box. Let me make it bigger, okay. So now this again has two compartments according to our example. So let us divide this box in half. This is the first compartment and this is the second compartment. Now what will happen? we will have another array at the first compartment of the main array, and also at the second compartment of the main array. Now again, as you can see, this array is represented by this box, which is the inner box, and this is the main array, so this is the main box. Now again, let's go inside. So we have again two arrays, so we will have to make two compartments inside this box. Let us again divide it in half. So two compartments here and two compartments here. Now finally, inside these two compartments, we have two arrays. So which store our elements. So this is the first array which actually stores the elements, and this is the second array which again actually stores the elements. Similarly here, this is the first array and this is the second array. So since this stores two elements, we will again have to make two compartments here. So 1 2 1 2 1 2 1 2. So here is our first element 1, here is our second element 2, again 1 2, again 1 2, and here again 1 and 2. So as you can see here, this is our main box, so it is represented by these brackets. Then this is our inner box, this is represented by these brackets, and this is yet another array which is inside this box, so this is represented by these brackets. So again what happens here is this outer box, which is the main array, has two compartments. So programmatically speaking, zeroth compartment, first compartment. So at zeroth position we have this array, and at first position we have this array, which is represented by these brackets. And again, since it is an array, it can store many elements. So this array stores two arrays at its zeroth position and the first position. Similar cases with this array. So zeroth position, first position, and finally at the zeroth position and first position we have another array which is this, which is the final array which stores the elements. So this is how the three-dimensional array works. So now these arrays have two properties, which are the shapes and dimensions. So I told you about dimensions here. Now let us see what are the shapes of array. So again, let us move to our one-dimensional array. So as you can see, this array has three elements, and there are no nested arrays inside this. So we can write its shape simply as 3 comma curly bracket 3 comma nothing, and we can close this bracket. So this is the shape of one-dimensional array. So you can actually find out the dimension of the array from its shape. So as you can see here, it is 3 comma nothing. So you know that it is a one-dimensional array. Now let us move to two-dimensional array and let us find out its shape. So here, as you can see, there are two nested arrays inside this 1 comma 2, and there are again two elements inside the nested arrays. So here what we can write is curly bracket, so two arrays, and again two elements inside each array. So 2 comma 2. Now as you can see, if you multiply this, that is 2 into 2, you will get 4. So there are total four actual elements inside the array, 1 2 3 4. So if you find out that this is the shape of given array, so you can actually find out its dimension, as there are only two elements in the shape of the array. Now let's move on to the three-dimensional array. Now here, as you can see, we have the main array, then another array, which is a nested array, and then inside that nested array, we have two arrays. So now let us define its shape. So as you can see, we have this main array. Inside it, we have two compartments. So it has two. So for the main array, it has two elements. So again, curly bracket. So 2. Now again, inside this nested arrays, which are sitting at the zeroth and first position of the main array, we have again two arrays. So again, each nested array has two arrays. So we will say has two arrays which for this nested array they are the elements. So again we will say 2 comma 2. And again, the final array has two elements inside it which store the actual values which are 1 and 2. So again, we will say 2. So now again, if you multiply all these values, so 2 into 2 into 2, you will get 8. So there are total 8 actual elements inside this array. So you can check it 1, 2, 3, 4, 5, 6, 7, 8. So now this is how you define the shapes of different arrays. So as you can see here, there are two elements in the shape of the array. Sorry, three elements in the shape of the array. This is because this is a three-dimensional array. So if you see three elements in the shape of the array, it is a three-dimensional array. Similarly, if you see two elements, it is a two-dimensional array, and a single element, and then it is a one-dimensional array. So this was all about dimensions and the shapes of the array. Also in Python, you can find out dimension of the array by printing array.ndim, and its shape can be found out by printing simply array.shape. So now let us dive into the code. So if you remember in the last video, I had explained that we have extracted the closing prices from our main data set, which was this column. So we have extracted it and we have stored it in the close price dataset. So now in Python, you can actually change the shape of an array by simply writing reshape. So it will have rows, this represents rows, and this represents column. Okay, so one thing that I missed out was here, as you can see, for one dimensional array, as I told you before, that it can be represented along a single axis. So if you correlate with the concepts of the dimensions, this represents the length of the array geometrically, and it doesn't have any other property. So we have left this thing blank. So if we find out similarly about two-dimensional array, you can represent it along again two axis as I told you before. So this represents the length of the array and this represents the width of the array. So when we go to the three-dimensional array, you can guess this, that this represents the depth, this represents the length, and this represents the width. And also here in two-dimensional array, since you can represent it by length and width, you can also correlate these two terms with the rows and columns. So this means that this particular array has two rows and this particular array has two columns. So now our array can also be represented like this. So 1 comma 2 and 1 comma 2. So this is our two-dimensional array. So as you can see, it has two rows, two columns. Since this is our one-dimensional array, we can represent it like this. It has three rows, or the length of this array is 3. So 1, 2, and 3. Since here it is nothing, so this is one-dimensional array. You can't actually represent the three-dimensional array in a similar way, but this represents depth, and this represents length, and this represents width. So now again, let's go back to our code. Here, as you can see, I have specified this -1. So as I told you before in the first part of our playlist, -1 means Python will automatically change the number of rows as per the data available, and we have specified here the column to be 1. So this means that our close price data set will have one column, and again the rows will be determined by Python. So once we have our close price data set ready, we have to again perform certain pre-processing calculations on it. So again, we are using the same standard scaler and again fit transform close price dataset. So we have scaled this dataset again to lower values. So here, as I told you before, we don't want the entire dataset. We only want 85% of it to use for training and validation purposes, and the rest 15% will be used while predicting our required output. So now let's go back here. Now I've again defined a new variable called final data, and we are using the scaled data. As from the part 1, you must be knowing that this is the entire data set which is scaled by using standard scaler. So here again we have taken slice of this data and not the entire data. So for that we are again using the slicing method in Python. So again this represents a row, and since we have not defined comma and then columns, so it knows that it doesn't want to touch the columns, and we need all the columns. So here, since I have defined a column, this means that start from the beginning, and here I have passed it an integer final data length, which I have calculated here. So if you have watched the first part, you must be knowing that this is the 85% of the data set. So what will happen is it will start from the zeroth index. It will calculate the 85% of the total number of index, and then end it slicing there. So now we have 85% of the data in final data. Now again, what we want to do is split the 85%. So let me go back to the whiteboard. Okay, so here is a conceptual representation of our data set. So now what I want to do is we have the 85% data set, and now of this 85%, I want to use 90% for the training process, and here the rest 10% will be used for validation purposes. So now this is called as validation data, and this remaining 90% of the 85% will be called as training data. So now let us understand quickly what is validation data. So here let me go back to our main diagram. So if you remember, our model takes the data, trains itself, and then predicts the data that we want. So during the training process, as I told you before, the model might think, okay, that it has to change the order of the contents. So first it might take triangle, then circle, and then again it might change the order. So how does it decide this order? So what it does is it it evaluates itself against a data that it has never actually seen. So this is known as validation data. Let me represent it by V. So now what it will do is during the training process, it will evaluate itself against the validation data and check that the order of the contents is right or wrong. So if it feels that okay, during this validation data, the predicted output is not matching the actual output, what it will do is it will change the order accordingly. So during the training process, it first takes the data, then uses this validation data to predict the output. So it predicts itself against this validation data and then automatically changes the order of its contents. So the validation data is actually very important during the training process, and all this stuff happens during the training automatically. Of course, if we provide the validation data. Okay, so now let's go back to our code. So just like before, I have calculated the training data length. So this is the 90% of our 85%. So here is the 85% and it's 90% of it. So an integer will be stored in this, which is again the index of the 90% of this 85%. So again, final data which is already which is already 85% of the actual data that we have stored in the CSV file. So what we will do is again we will slice out the 90% as the training data from this final data. So again, let us start from the beginning, that is the zeroth index, move down till training data length. So what it will do is again it will start from the beginning, that is the zeroth index, so 0, and then suppose let's say that 82 index is the 82nd index is what is the 90% of the 85% of the entire data set. So what it will do is start from 0 and then till 82 it will take all the rows and then store it inside the training data. So now we have our training data, and now what we want to do is here we want the rest 10% as the validation data. So again, we will start from the 85th index as according to this example, and then maybe move on to 90 or 95 or something like that. So again, as you can see here, validation training data we have done. We have taken our training data. Here is the validation data. Again, we will slice it from the 85% of the total data. So this is the total data, and then training data, and then start from training data length till the final data length. So then we will start from 90% of the index till the 100%. Okay, so now again let me explain it from a diagram. So let us take this 85%. So this is our complete data. Here I am taking only 85% of the complete data. So 1 and then 85. Okay, so this is 85% of our complete data. Now I what want to do is, let us say that 90% of this data. So okay, so 90% of 85 will be something 76.5. So it will round off to 77. So let us say that this is 77th index of our data. So what it will do is, it will start from the first index, go to 77, and then take this as and then store it in the training data. And then the remaining 10%, which is from the 77th index to the 85th index, it will store in the validation data. So this is what we are doing here. By the way, if you notice that the final data is sliced from the scale data, so now we are already using the scale data and we are no longer using the original data. Also here I have used math.sil to round off to the nearest integer value. So instead of 76.5, it will take 77 and then store it in the training data and then store the rest 10% in the validation data. So here you can see that final data, which is the slice of scale data, that is 85% of the scale data. Fine. So final data is 85% data. So now we are taking it and again slicing it from 0 to the, that is the 0th index to 77 in the index, and then storing the 90% of the 85% scale data in the training as a training data, and then we will use the remaining 10% as validation data. So again we will start from the training data length. So let us assume that training data length, according to our this example, stores the 77 integer. So what it will do, it will start from, since before the colon we have passed training data length, which is in this context 77. So it will start from 77 and then till the final data length, which is 85%. So we have here defined the limit, so for the slicing, and again we have wrote nothing after the comma, so it knows that we don't want to touch the columns and only, and we want to slice only the rows, and we want all the columns. So it will start from 77 till the final data length, which is 85% of the data. So this is all about today's video. In next part, that is part 3, we will understand what are neural networks and how does this actually works, the model actually works, and what are actually the contents of the model. Thank you.